less than or equal to the nth term, and we need the limit of the nth term to equal 0, and when that happens, the series converges. And the best example was that first one you asked me about today. I was so happy you asked. Take a look at this one. This one even has a name. It's called the alternating harmonic. The harmonic, do you recall we talked about it last time? Alternating harmonic. It was a P series, and the P value was 1, and it diverged, guys. It diverged. So now we're going to take a look. Say what?
It keeps going, right? Was that?
They all keep going.
Right.
What do you mean?
When you say that it converges, then doesn't it stop?
No.
It just
No.
stops to a-
It means that I can find the sum. It never stops. All of these things are infinite. Keep going, keep going, keep going. But it's like adding.
It's like 1, 2, 3. You can't add all that, like all of them together, because there's like infinite.
Yeah, that's
numbers.
another infinite series.
Whereas like that,
And that one won't pass the nth term test.
yeah.
Because the limit of the nth term doesn't
Not
equal 0. So we can't sum up 1 plus 2 plus 3 plus 4, dot, dot, dot. They all go to infinity.
Whereas
The
that-
question is, do the pieces at the end get small enough that pretty soon they kind of drop off?
So small.
So this alternating harmonic, even though we're going to, we better write out a few terms. I'm not so convinced you know what it is we're adding up here. So when n is 1,
Negative 1.
negative 1. When n is 2.
1 half. Negative 1 third. 1 4. Negative 1 fifth.
Okay, that's what we're trying to add up.
Yeah.
When we worked on it in the previous section, it was all plus signs. And even though the terms get smaller and smaller and smaller and smaller, it can't be added up. Couldn't be added up. So if we take a look at this alternating harmonic, we need to ask, is the n plus first term less than or equal to the nth term? So do it, but ignore the pluses and the minus. Is a half less than or equal to,
Yeah.
the
A half
n
is
plus-
less than 1.
Because that's n plus 1. 1/2 is n plus 1.
Thank you. A half is less than or equal to
1.
1 when I ignore the minus sign. Is a half, no, let's go here. Is a third less than or
a half.
equal to a half,
Yeah.
but you can't count the minus sign.
Yeah.
So it's basically the function, if the series is decreasing
Decreasing.
without, considering the negative of the positive.
It's not quite that strong, because the terms.
Not increasing.
You can't
Yes,
equal.
it's non-increasing, yeah. So I've got that 1 over n plus 1 is always going to be less than or equal to 1 over n. And this argument you can easily make when the bottom gets bigger, the fraction gets smaller, so we're good there. And the limit of the nth term, is 0. Those are the two conditions for an alternating series to converge.
So then
In our past, we didn't want this to happen. Why not?
That one converges,
Wait,
but
wait, wait. In the past, we didn't want this to happen. Why not?
because then if it equals 0, that means that it was no conclusion. It could either be convergence or divergence.
And you had to go looking for another test. The nth term test for divergence only works if it doesn't equal 0. So in the past, this was a very bad thing. Today, we're happy. But it only works if the signs alternate. Okay, now your turn.
I was just saying, so if it converges when you have alternating signs, but if you get rid of the alternating signs, then it's, that problem diverges.
That has a name. That's a little later in today's lecture. How good of you to ask. It's coming up. I would like you to try one. Open up your book